Okay, hi everyone. So this is our first lesson for our second topic, which is logarithmic and exponential functions. So for today's learning outcome, we'll be learning what is the relationship between logarithms and indices and how to use the laws of logarithms. So just for your knowledge, right, you are not required to know how to change the base of logarithm in this topic, meaning that you are not going to use that part. Okay. So today's lesson will be quite a easy one because it's just like a recap or like a revision on the content that you have learned previously in IGCSE. Okay, so for introduction, I'm putting in the part for exponent. I mean that is not the main focus of our topic here, but then I think it's helpful for us to like do some revision on exponents since that you need to learn on logarithm because they are interrelated with each other, right? Okay, so like basic knowledge. So the exponent or like the power of a number tells you that how many times of the base is used as a factor in the multiplication. So meaning if we write that 2 to the power of 4, meaning that we will use 2 for 4 times in multiplication for us to get 16. So 2 is called as the base and then 4 is the exponent, or sometimes we call it as power. Okay, so now let's look at some of the laws of the exponent that you should know already at this time. So we are just going to do some fill in the blanks together. So just some recap for you. So a to the power of m multiplied with a power to the n. So you will get, yeah, a to the power of m plus n. All right. So if it's divide, so meaning it will be a power m minus n, correct? Okay. So if you have a to the power of m in a bracket to the power of n, so meaning that you will need to multiply the m and n together. Okay, so if you have a to the power of m multiply b to the power of m, meaning that you can combine them together as long as you have the same power, meaning that you can multiply a and b together and together with power of m. Okay, so this is the one that we used previously in the binomial expansion. Okay, same thing to divide. So if you have the same power for both denominator and numerator, then what you can do is you can combine them together. So a divided by b to the power of m. Okay, so for any number that has a power of 0, they will give you an answer of 1. So meaning no matter 5 to the power of 0, x to the power of 0, as long as they are with the power 0, they give you 1. So if you have a negative indices, meaning that you should change it into a fraction. So meaning 1 over a power m. Okay, so for example, if let's say we have like x negative 2, meaning we'll write it like 1 over x squared, something like that. All right. Okay, so if a m over n, so you remember the m is just like the normal power that we have, but then we have a like 1 over n. So meaning we will do the reverse of the power. So meaning it will become like a. So let's say we are trying to look at the part that we are not having like 2 and 3. So if I have am, then n over 1. So meaning if I'm going to put it in a root, then it will be something like this. Then am inside, then you have your n outside. Okay, so depends on, like for example, if you have uh x to the power of 3 over 5, so when you write it, then it will be like x 3 and then 5. Okay, so these are some laws of exponent that maybe will help you when we try to solve logarithms in the future. Okay, so now let's try to look at what is that mean by logarithm. Okay, so I just want to let you know that your textbook try to arrange everything like they did it like log to the power of 10, sorry, log for the base of 10 as one subtopic and then log to the base a as one subtopic, which I think that is not necessary. So that's why I just try to do a general one. Then after that, I put inside like log 10 is one of the special kind because they means the same thing. I mean, it's unnecessary for you to learn 10 first, then after that, look at general. Okay, so we are just going to look at general. Then after that, one of the general type is like log 10. Okay, so logarithm to base a, so we know that if y equals to a to the power of x, then you can write it in a way that like x equals to log with base a and y. So meaning that let's say if I have 5 to the power of, sorry, yeah, okay, can let's say 25 equals to 5 to the power of 2. So meaning that I can always write it in such a way that log. So you see my a and my a. So the base of my exponential will be the base for my log. So the base here is 5. Okay, and then after that, my answer for my exponent will become the number that I used to log, then equals to the answer is the power. Okay, so normally we will describe this word, this rule as like log ay is the power that a must be raised in order to get y. So for example, when you look at this, meaning that what is the power that 5 must be raised for you to get 25? So in a short word, meaning that 5 power what gives you 25? So that's why your answer is 2. So for example, if I have log 2, 8, so what's the answer? So it will be 3. Why? Because 2 to the power of 3 give you 8. So basically, when you answer what is log, then you just remember lah, what is the power that you should put on the base for you to get this number. So that's why log to the base of 2, 8 equals to 3 because 2 to the power of 3 gives you 8, right? Okay, so no matter you write in this case or write in this case, they are equivalent. They are actually means the same thing. So logs undo the exponential and technically speaking they are inverse function. So meaning when I write y equals to x plus 1 and when I write x minus and when I write x equals to y minus 1, they means the same thing and they are the inverse functions of each other, right? So it's the same thing like when we say exponential and log. Okay, so one of the special kinds of logarithm which we normally use it for us to solve an equation and so on is log to the base 10. So for log of base 10, right, normally we will write it in a way that if you see like log without written any base, then you can assume that it's log 10. Okay, or the other way we can use LG. So both of this symbol means log 10. Okay, so same thing, we know that some of the useful principle for logarithm. So meaning that, like for example, if I see log base a and a, what is the answer of it? So it's the same thing. You can think of what is the number of the power that I should put on a for me to get a. So you should know that a to the power of 1 gives you a, right? So that's why a log a gives you 1. Okay, so you can remember anything like log 5 equals to 1. So log x give you 1 as well. Alright, so anything with the base and the number that you use to log is the same, they will give you the answer of 1. Okay, so log the base of a, then 1. So what is this? So a, what is the power that gives you 1? So it will be 0, right? So log a1 gives you 0. Okay, so you can remember anything no matter what is the, so like log 1 gives you 0. So log x1 gives you 0. Okay, so as long as no matter what base that you have, as long as you are doing log 1, they will give you the answer of 0 because any number you need to power 0 to give you 1. So that's why log a1 equals to 0. So the next one, log a, then ax. So how about this? Same thing, let's try to change it into exponential form first. So this one I have my a, right, for my base, and then after that this is the answer that I should get. So a to the power of what will give me ax. So I must have an x here, correct? So that's why my answer here is x. Okay, so a to the power of x give me ax. So that's the idea. So that's why if you have anything that you have like log base 5 and then 5x, they'll give you the answer of x. So if I have log 3 power 4, so what's the answer of this? It will give you 4. Okay, as simple as that. So it's the same thing now. Later we will learn the power indices, then you can know that log 3 gives you 1. So that's why when you bring 4 in front, then after that 4 times 1 will give you 4. So it's the same thing. You can use that idea to prove it also. Okay, so the next one, same thing. So let's try to change it into a log form. So meaning that normally this is the base for the indices, right? So we'll write it as the base of our log as well. Then after that, the power here will become our answer for the log, right? So now we have log A. So what's the number that I should put it? So they are equivalent, then it should be x, correct? So the answer of this will be x. Okay, so meaning that you can just remember it as long as I have like 5 log 5 and for example like 3, then this one will give me the answer of 3. Okay, so if I have like 10, then log 10, then after that 5, so this one will give me the answer of 5. Okay, so as long as they have the power of like the same base, and so yeah, because of when you try to rearrange it, then this is what you get, right? So for example, if let's say I know that this one equals to x already, you see when I rearrange this thing, so I'll have log base and then my answer then equals to whatever for my power. So this is correct. Yeah. Alright, okay, so now we'll be looking at first 6 example first before we move on to the next part of the notes. So now kindly move to the page that you have your example. So these example are quite easy questions, so I'm just going to go through it very quick as a revision for you. Okay, so A, convert 10 to the power of x equals to 58 to logarithm form. So method 1, easy, then you can just use the idea that I said just now. So the base of your indices will be the base of your log. Then after that, your answer will be the number that you use to log. Then after that, your power will be the answer. Okay, as simple as that. So meaning the base of your indices become the base of your log. Then after that, your answer become the number that you use to log. Then after that, your power is the answer for your log, because it's like 10 to the power of x gives you 58. Okay, or method 2, if you want to use this, you can also. So meaning you have 10x equals to 58. Then what you can try to do is you log both sides. So log 10, then x equals to log 10, 58. So if you remember just now, there's an identity tell you that log a x equals to x, right? So that's why you left with x here. Then equals to log 10, 58. So you can see it's the same thing lah. Yeah, but then I would say just use A will be much more easier. Okay, B. So solve 10x equals to 58, then giving your answer correct to three significant figure. Okay, so since you already change it into log, so meaning x equals to log 10, 58. So just use your calculator. So in your calculator, your log 10, they are not they are not written in like log 10, they will just write like log. So just press like log 58 for you to get the answer. So three significant figures, so you will be getting like 1.76. Okay, so that's number 1. So let's move on. Okay, number 2, convert log 10x equals to 3.5 to exponential form. So same thing, just use the definition to do that. So the base of your log is the base for your indices. Then you know that 10 to the power of 3.5 give you x, right? So 10 power 3.5 give you x. Okay, so just like that, then you can get you can get your answer already. Or if you want to use the idea of x, then what you can try to do is log 10 x equals to 3.5. Okay, so that's a law just now that we learned, like log a, the anything to the power of the same log base, then you can get the answer, right? So meaning that I can, if you want, then what you can try to do is you can try to change like log 10 x, then same thing. Okay, so meaning that you are trying to put both sides as an exponent of 10. So 10 log 10 x will give you x, then after that 10 3.5. So you can see you get the exact same answer. But of course I wouldn't recommend you to do this. Yeah, I'm just telling you that, I mean, there's this option in your textbook that they try to teach you like this. But I would say just understand what is the definition of indices and and logarithm, and just use the first method lah. Yeah. Okay. So B, same thing. So they want you to solve it. So log 10 x 3.5. So since from A you already know that x will be equals to 10 to the power of 3.5, so just use your calculator and press 10 to the power of 3.5, and you should be able to get your answer for three significant figure as well. So that's why 3160. Okay, so let's move on to number 3. Okay, so number 3, this is quite an easy one. So what we will try to do is, yeah, just go through it quickly. Okay, so you have log 10, and then after that 10,000. Okay, so yeah, the idea will be like 10 to the power of what give you 10,000, right? So how can you write it in a way that maybe like easier for the readers to understand? So you are going to change the same thing. So how can you change this into power of exponent with a base of 10? So this one you need 10 to the power of 4, right? So you know that log x will gives you x. So that's why 4. Okay, so same thing. So the second question, log 10 0.0001. So log 10. So same thing you ask yourself. So 10 to the power of what gives you 0.0001? It will be -4. So that's why log 10 10. So it will eliminate each other. So that's why -4. Okay, so let's move on to C. So log 10,000 and then 10. All right, so this question you will need to change it. So log 10, same thing, we need to change it into a exponent that with a base of 10 as well. So that's why, so 1000 here, you will change it to 10 to the power of 3. So how about here? So it will be 10 to the power of 1 over 2. Correct? So after that, then you can combine them together. So remember the law of indices. So if you have the same base, then meaning the power, you should add them up together when you multiply them. So that's why it's 10. So when you add them up, then it will be 3.5. Or if you want to write 3 and 1 over 2 can also lah. It means the same thing. Okay, so now you have log 10 10 already and 3.5. So that's why your answer is 3.5. Alright, simple as that. Okay, number 4 is an easy question as well. So same thing, I'll recommend you to use the definition. So straight away, log. Okay, so the base of indices is the base for your log. Then after that, your answer, then it will be equals to the power. Okay, so after you write, then you can check 5 to the power of 3 give you 125, that is correct. Or the other way, if you want the harder way, which I don't recommend, but yeah. So 53 equals to 125. So what you can try to do is, you want to change, eliminate the 5 here. So that's why just do like log 5, then 5 to the power of 3. So log 5 as well here. Okay, so log 3 will give you 3, right? So equals to log 5, 125. So you get the exact same answer. Okay, now number 5. So change the log into exponential form. So same thing, the base of your log will be the base of your indices. Your answer of log will be the power. Then after that equals to x. Okay, as simple as that. So the same thing, if you want to go to the hard way, then it will be like log 3x equals to 2.5. So what you can try to do is try to change everything into like the exponential form. Okay, because you want to get rid of the log 3 here, so that's why 3 log 3. Then after that 3 2.5. So you have 3 log 3, so you're left with x then equals to 3 2.5. Okay. Okay, so number 6 is the same thing like the number 3 just now. So what we can try to do is let's try to change the number that you log to the same base. So log 2, right? So that's why you try to change 16 to the base 2 also. So log 2, so 2. So 2 to the power of what give you 16? So it will be 4, correct? So log 2, 2. Then you eliminate it, so you're left with 4. Okay, or in the other way, you know that log 2 to the power of 4 give you 16, so that's why log base 2 16 gives you 4. Okay, B, so log 3 1 over 9. So same thing, how can you change 1 over 9 to an exponent with base 3? So it will be 3, then after that negative 2, correct? So if you can't do this in a short, then what you can try to do is you change it one by one. So you know that 9 negative 1, correct? Then after that log 3. So 9 you change like 3 2, correct? So you have log 3 3 negative 2. So you can multiply them together. So this is how you get to negative 2. Okay? Okay, so the last example before we move on to the next part of the notes. So simplify this. So log x x, 3, and x. So what we need to do is simplify it. So what we can try to do is start from the index first. Okay, so we have like cube root of x. So we know that in indices, we can change it to x to the power of 1 over 3, right? So sorry, this should be x. Okay, so this is x to a power of 1 over 3, then divide by x. So from the law of the indices, we know that when we have indices that divide by each other, so the power we can always minus, right? So this is power 1. So log x x, so 1 over 3 minus 1 gives you negative 2 over 3. So that's why you have log xx. So that's why you left with the power, so which is negative 2 over 3. Okay, so now we'll try to go back to the notes to continue the next part. Okay, so now we'll be looking back at your notes part. So we'll be looking at some of the laws of logarithm. So we are going to learn from it from the proving part. Then after that, you know how all these laws come from. Okay, so when we have log to the base a, then after that xy, then when we try to write it, then we know that the multiplication law will give you a addition, right? So this is what we learn normally. But how do we actually get to this answer? So let's try to do this. So if you have an index that is x equals to a to the power of p, and you have y equals to a to the power of q, when we try to change this into log, what do you get? You have log a x equals to p, right? So the same thing, you have log a y equals to q. Okay, so now let's try to put it. If let's say I have x multiplied by y, so meaning that what do I have? I have ap times aq, right? From the definition here. So now if we have AP multiplied with AQ, meaning we can always plus them together. So AP plus Q, correct? So XY equals to A to the power of P plus Q. So now let's try to log both sides. So log A XY equals to log A, log A P plus Q. I'm just trying to add log A in front of these two terms. So what do you realize that what you can get? So log A xy, correct? Then it will be equals to, so log A. So what do you left? You left with P plus Q. So what is P and what is Q? So log AXY equals to P plus Q. So your P is log AX and your Q is log AY. So this is how do you actually get the identity from. Okay, all right, so now let's try to look at division. So it's the same idea. So let's say if I try to put if my x equals to AP and my y equals to AQ. Okay, so let's try to change it into log first. So log base AX gives me P, and the other one log AY gives me Q. So now it's divide, right? So that's why x divided by y will gives me what? So compared to here, so I have AP divided by AQ. So x over y gives me AP minus Q. So same thing, let's try to log at both sides. So I have log AX over y. Then I have log P minus Q. So same thing here, log AA, you left with P minus Q only, right? So the front part, still keep it as the same. Then after that, log A x over y. So what is your P? Your P is log AX. So log base A x minus log base A y. So you see, this is how we get our second identity, which log AX over y gives you log AX minus log AY. Okay? So now let's look at the next one, which is power law. So the same thing, let's try to see how do we get the answer. So the same thing, what we can try to do here is we try to define one index here, which is like x equals to a to the power of maybe p. Okay, so if x equals to a to the power of p, meaning that when we try to change it into log, then you will have log a x gives you p, correct? So now let's try to continue it. So because we want xm, right? So that's why we try to raise the power here to xm. So that's why for your AP, you will need to raise it to the power of m also. So you have xm equals to a to the power of pm. So let's try to log both sides. So log axm equals to log apm. So you will realize that log axm will be equals to, so log aa. So you left with pm, correct? So I try to change it around, so I can write in the form of like mp equals to mp. So what is p? Log a x m will be sorry, I don't have maybe I write here. Okay, so mp, so log a x m will be equals to, so m, then what's your p? My p is log a x, right? So m log a x. So you know that this is how is that come from. So that's why log a x to the power of m, you can always bring forward. So normally sometimes you will say you will multiply the m in front, right? So that's the idea of it. So log a x. So this is how you actually get this identity. So the second one is the same thing like what you have learned previously. So if you have something that is like 1 over x, so you can always write it in such a way that x minus 1, right? So that's why this you will get negative. Okay? So anything that is like 1 over x, then you can normally change it into negative log ax. So for example, if I have log a 1 over 5, then I can always write it negative log a 5. they will give me the exactly same thing because I the negative 1 here, when I bring it back, then I get negative 1 as power, right? So 5 to the power of negative 1 will give you 1 over 5. Okay, so just like that, then now we'll be looking at some of the questions together. Okay, example 8. So use the laws of logarithm to simplify this expression. Okay, so we use the law of logarithm that we have learned just now. So we can write it down so that you can remember. So like log axy will be equals to log ax plus log ay. Then you have log a x over y gives you log ax minus log ay. Then you have the power law, which log ax power m will give you m log ax. Okay, so when you use the power index, right, please make sure that your m must belong to x only. So meaning that we are not, so if you are saying something like this, okay, this and this, they means the different thing, and this one is not equals to this one. So you must make sure that when you try to move the m in front, it means that your m, the power here, it must be belong to x only. It's not the whole thing of the log power m. Okay, so this is like just for you to be much more careful. Okay, so log a 3 plus log 2 5. Okay, so they have the same log and this is plus. So that's why we'll try to simplify by using the multiplication law. So meaning I can always combine them by multiply them together. So 3 times 5, which gives me log 2, 15. Okay, so B, I have log 3, 8 minus log 3, 4. So this is minus, so that's why we'll use the division law. So log 3, then x divided by my y. So I have log 3, 2. Okay, so C, 2 log 5, 2 plus log 5, 3. So this is plus, so that's why we know that we need to use the multiplication law, but then we have a 2 in front of like the log 5. So what we need is we need to use the index, the power law, so to help us to bring the 2 to the as the exponent of the log that we have. So that's why this one will become log base 5 and 2, 2. Okay, plus log 5, 3. So now you are in log ax plus log ay already. Then now you can combine them. Okay, so this is multiply. So 2, 2 times 3. So 4 times 3, which is 12. So log 5, 12. Okay, example 9. So given these two logarithms, so you need to express all these terms in terms of x and y. Okay, so this is like the opposite of what we have learned in the is the opposite operation of like example 8, that what we try to do here is we try to eliminate the log here. Okay, so same thing. So let's try to copy down the questions first. So log 4 P5 minus log 4 Q2. Okay, so you can look at what is given with in the questions first. So you are given log 4P and log 4Q. So now you have log 4P5 and log 4Q2. So we know that we need to eliminate the power here. So we can use the power law. So what we try to do is we move the 5 in front of our log, right? So minus, same thing here, 2. So log 4Q. So now we have log base 4P already and log base 4Q. So we can straight away substitute. So 2x minus 2y. Okay, so B log 4 square root P plus 5 log 4 cube root Q. Okay, so the same thing, let's try to change the P and Q into index form first. So P 1 over 2 plus 5 log 4 Q 1 over 3. So same thing, try to bring it in front of the log. So 1 over 2 log 4P plus multiply. So I get 5 over 3 log 4Q. Okay, so as I expand, then I will be able to get 1 over 2x plus 5 over 3y. Okay, so the last one, C log 4 64 over P. So let's try to expand it. So this is divide, right? So log 4 64 divided by 4. So we can always use the division law to help us to expand it. So I'll have 64 minus log 4p. Okay, so log 4p, I know that this will become x. So how about this? So log 4, we need to change 64 to the exponent that with a base of 4. So 4 to the power of 3 gives us 64. Then log 4, then you're left with 3 minus x. So this will be your answer. Okay, so actually this lesson is quite easy. It's just like a recap for you before we move into like how to solve the equation, the inequality and so on. So just a time for you to do your revision. After that, for the next two lessons, we'll be moving into the part that is like much more important. Okay, so take this time to make sure that you understand everything and do some of the exercise. All right, thank you.